At Simio, we're in the business of showing you the future. Our intelligent technology gives you unprecedented insight into complex systems to identify and solve today's inefficiencies and tomorrow's challenges. The Simio solution provides a low-risk opportunity to drive transformational change. Our true digital twin models capture all the constraints, business rules, and decision logic that define the operation of your system. When powered by your data, easily evaluate unlimited scenarios and deliver optimized solutions. No matter what industry you're in, eliminate your greatest operational process and scheduling challenges with a Simio digital twin. See your future success, Simio.
All right, perfect. Welcome everyone to Simio Solution Series 2024, and Happy New Year to everyone, and Happy New Solution Series to everyone. Today's session is going to be Fundamentals of Simio, Basic Features and How to Use Simio for New Users. My name is Dan Vasilini. I'm the VP of Global Sales over here at Simio. Doing most of the talking and presenting today is going to be Jeff Smith, who is our Vice President of Training and Academic Programs. Our emails are listed there for future communication if you need to reach out to us. And during today's session, you might have a question or two. And if you don't want to type it in, or if you want to reach out to us in the future, I would suggest jotting our emails down so that you have them. On the bottom of the screen, the QR code there. We're always looking for feedback on our sessions, and any type of feedback or anything you'd like to tell us about what you've seen here today or in prior solution series, or what you'd like to potentially see in future. Encourage you to scan that QR code and just give us a little feedback so we do know how we're doing, as well as anything that you are interested in. Some housekeeping items for today's session before we get started. Just be aware today's session is being recorded for replay purposes. If you'd like to go back and rewatch this session or suggest it to a friend or a colleague, we will have this live on Simio's webpage within usually about 24 hours or so. We have the recording up so that you can go back and watch it. So if you pick up something here today, or we go too quick for you, or like I said, you want to suggest it for someone else to watch, it will be on simio.com once this session ends, probably within about 24 hours. Also be aware that today's session is, that everyone will be on mute when you enter. So you will not be able to talk to us during today's session. If you do have a question, somewhere on your screen, there should be the GoToWebinar dashboard. In that dashboard is a question box. The easiest way to ask a question to us is simply just type it into that question box. It'll pop up. If the question is relevant to something that Jeff's talking about, I will try to interrupt him and ask the question at that point in time. If your question is more generic in nature, or we missed the point of asking the relevant question during that time, we will leave time at the end that I can go back and ask questions. Today's session is scheduled for about 60 minutes. Jeff has about 45 to 50 minutes to present. So we will go into his presentation. Like I said, we will try to leave the time at the end for questions if we do get to them. All right, we have our next two solution series scheduled, April 18th and May 16th. We're going to do some warehouse modeling techniques and best practices in April. And then in May, we're going to talk about counter element, new feature, and other elements such as time and monitor, etc. So please jot those down. You will get alerted to the sessions coming up via email like you were alerted to this session. But in case you want to register now, you're more than welcome to go to our webpage. These sessions are already up there that you can register for, so you don't forget or you miss the email. You can register for them now, and you will be alerted right as the time comes. One more thing before we get into Jeff's session is Simio Sync 24. For those of you that are new to Simio, perhaps a new customer, perhaps you are joining this webcast for the first time, we have an annual session or an annual user conference called Simio Sync. We are doing this session online like we have the last few years. It is currently scheduled, or it's actually scheduled for March 6th and 7th. We're going to cover a bunch of the different topics you can see here in the bulleted points. I'm not going to read through those, but you can see what we're going to be covering. We have speakers from many different industries, including Johnson & Johnson, Northrop, Chevron, Penske, and more. So if you are interested, please go to this area right here to register. It's on our webpage. If you click the Simio.com webpage, it is the first thing you'll see when you go into the Simio webpage, or if you want to go to this link, you feel free to click this link and you can get there that way. The sessions run, they are recorded. They run from, I think it's around 10 in the morning to around 1:30 in the afternoon Eastern time. So you have a little window there to watch. It's 2 days. It will be recorded, but I highly recommend getting registered now so that we can get our attendance and everything scheduled. You will be able to ask questions during those sessions similar to the solution series you're attending here today. All right, one last time. I appreciate everyone coming today. We have a nice big crowd. There's a lot of you out there. The QR code on the right side, once again, if you could scan that and give us some feedback on today's session or future sessions, that would be great. Otherwise, I'll turn it over to Jeff. Jeff, you are ready to go.
All right, well, let's see here. Hopefully you guys, everybody can hear me. And I should be, can you see my screen now, Dan?
Yep, looks good, Jeff.
All right, thanks. Thanks for the introduction, Dan, and welcome everybody. As Dan said, I'm going to talk today about some fundamentals of Simio. And it's just a little bit of background. Dan already introduced me. I'll just note my email address here and that I've been doing this for quite a long time, as you can see here. The abstract, I just repeated the abstract that hopefully made you decide you wanted to come to this, that we're going to actually be building a Simio model and demonstrating some capabilities. And my goal here is to have, no idle talk and no hand waving, as I say here. Of course, that's an objective on my side, and only you guys can be the judge of that. So let us know how we did on the feedback. We're going to spend the vast majority of time here inside Simio, but I want to talk for just a second about the outline and what we're going to do. We're going to talk about some of Simio's main features, particular objects, libraries, and the standard library in particular. We'll dip our toes into animation, a little bit of experimentation and data handling, some of the fundamental constructs of Simio. When we talk about building Simio models, especially when you are new to Simio, it's basically comprised of placing and connecting Simio objects, setting property values for those objects, using data, either directly entered or through data tables, and then adding animation. Once we have models, then we use those models for experimentation, decision-making, planning, scheduling, and so on. So that's kind of basic structure of what we use that for. So before I jump in and start building this model, I want you to keep one thing in mind. Simio is really powerful, it has lots and lots and lots of features. And what we're gonna do here in this 45 to 50 minutes is really just scratch the surface. And when I put this together, I chose to go in depth on a very small number of features rather than to throw a whole bunch of features out to you. So if there are things that you'd like to see more of, and I'm sure there will be, I'm sure there'll be times in the presentation where you'll say, gee, I wish we could go further into this. When you see those, just let us know through the feedback for the solution series or directly by email. The solutions team uses the feedback to guide future sessions, and who knows? Maybe Dan and Angela will let me come back for a future solution. Also, as Dan mentioned, feel free to ask questions, and then he will moderate in the background. Okay, so having said that, let's jump right in. So I'm gonna go and I'm gonna open Simio. Here's what you would see if you started Simio. You would see over here on the left side, right here, we have our libraries, the standard library, and then the project library, the two that we're particularly interested in for this session. Over on the opposite side here, we have the properties window and what we call the navigation window. We'll see all of these things as we move forward. And then across the top, we have the ribbon. And in particular, one ribbon I will point you to is the support ribbon. And there are two things of particular interest here in the support ribbon. One is your license information, which when you talk to us either through support, these are things that we want to know. And then also for the extensive amount of help that is included with Simio. So all of that is accessible through the support ribbon. And then this main area here that we see is called the facility view. And when we talk about the basic modeling process of placing and connecting objects, what we mean is that we're going to drag those objects from the libraries onto the facility view, connect them up, and then set the property values. So let's do that real quick. So what I'm going to do is I'm going to zoom out a little bit. I'm going to add a source object. I'm going to add a couple of server objects. So there's one, there's another one, there's another one, and then I'm going to add a sync object. Then I'm going to reach down here in the project library and add a model entity. So that's the dragging objects to the facility view. And now I'm just going to click run, and I'm going to let the model run for a second while I talk about what's going on here. So the objects that we place, the source object is used to create entities. The server objects are used to model a capacitated resource and process entities. And the entities, when I run the model, they disappear here, represent things that move around in our model. So if you think about a customer service system, these might be customers. If you think about a manufacturing system, these might be parts or sub-assemblies. Packages, shipments, orders, and so on. So the things that move around within our system. Entities also can represent more abstract things like failures and placeholders in a schedule and abstract batches and so on. So we'll see a little bit of that in our demonstration here. And so what you're seeing here when I run in default, I haven't told Simio anything other than placing these objects. You can see that we're creating entities and they're actually moving around through what we call free space. And so this default behavior, when an entity leaves one object, it just goes to the closest object because I haven't told it otherwise. So if I were to move this server up like that, you can see that the entities are now moving from server 1 to server 3. And then if I were to move the sync over here, they would go directly here. So that default behavior specified go to that closest object. Now this can be useful in some cases, but in general, we want to be more specific about how entities move through the system. So the easiest way to do that is by using links. And I'm going to go over here and I'm going to connect these up with what we call paths. So I'm just going to click on the output node of source 1, the input node of server 1. And I'm going to do the same thing from server 1 to server 2. Same thing from server 1 to server 3. And then I'm going to connect the server 2 and 3 to the sync. So there we go. And so what the path objects say is give the direction on how entities should move. And now the proximity doesn't matter. So I can move the object instances around, closer, further, it doesn't matter at all because the path dictates the direction. So one thing to keep in mind when we look at this, this model that we've built is we haven't really told Simio anything about how this behavior works. So I haven't said anything about how entities should arrive. I haven't said anything about how the processing should occur. In this case, I haven't said anything about how does it make the decision of go to server 1, to server 2 or server 3. That's all done through setting object properties, which I'm going to do here in just a second. But before I do that, let's just take a quick view of what's going on here. So you can see the entities moving. And if you look down here in the lower left corner, you can see the simulation clock. And so you can see we have two different views of the clock. We have a real number value, which represents simulated hours. And then we have a calendar date, which represents, well, a specific day and time that the model is running. So if I just jump over to my run ribbon and go to fast forward, I'm basically turning the animation off and telling the model, go ahead and run until the end of the model, which by default is 24 hours, as you see here. And now I can stop the model and go look at the results. And what this is going to show me is we have run the model for 24 hours of simulated time. And during that time, we've tracked statistics and performance metrics that are defined by the object properties. And you can see over here on the left that these are listed by object type. So we have our model entity, we have our path objects, we have our 3 server objects, and then down below we have the source and the sync. So we look at the performance metrics based on that run. So we're going to come back to this in just a little bit, but I'm going to leave that for now and say as I said before, we haven't said anything about how these processes work. And so we're going to do that really quickly, take a quick look at that, because in general, I want to have my system mimic some real system, right? I don't want just the Simio's default arrivals. I don't want Simio's default processing at my resource objects. I want to be able to specify mine. And so that's done through object instance properties. So I'm going to click on the source over here, and then I can go look and see that object's properties over here on the right side. In particular, the mode, the arrival mode, the default arrival mode is an inner arrival time mode, which basically says Simio samples a random variable and then fast forwards to that time and creates an arrival, and then it samples again and creates the next arrival, and so on and so forth. And the default inner arrival time expression, random.exponential 0.25 minutes. So by default, what Simio is giving us is a Poisson arrival process with a mean inner arrival time of 0.25 minutes. If I want to change that, I simply change this expression, or I change the arrival mode to get a different type of arrivals. For this simple model, I'm not going to change that particular value right now. We'll do that here in a little bit. When I look at server, I'll just pick server 2 here, and the properties of interest to us here are the initial capacity and the processing time. And so this default value basically says my server can be processing one thing at a time, and when an entity arrives and accesses that unit of resource, it's going to follow a triangular distribution for the processing time. So a triangular distribution, if you're not familiar with, is a very common distribution in simulation. If you ask someone, like, let's say I'm going to go to Chick-fil-A and order my lunch, and I say, how long does it take for you to order? You're going to say, well, it takes usually about a minute. Sometimes I can do it in 30 seconds, and sometimes it takes 2 minutes. And you've just described the parameters for something like a triangular distribution. So it lets us describe randomness, but in a somewhat controlled way. So what I'm going to do here for this one is I'm just going to take these default values and double those values. So instead of 0.1, 0.2, 0.3, I'm going to make it 0.2, 0.4, and 0.6. Here we go. And then I'm going to go down to server 3, and I'm going to do two things. First thing I'm going to do is quadruple this time. So it's going to be 0.4, 0.8, and 1.2. And then I'm also going to change the capacity from 1 to 3. And so now what I've just done is I've said I've got these 3 server instances, and they all have the same general behavior, but I've customized the specific behavior. So the first one, server 1, we just use its default values. For server 2, we've doubled the processing time. For server 3, we've quadrupled the processing time, and we've also changed its capacity to 3. So you can see here that now we are processing up to 3 entities simultaneously on server 3. So customizing the behavior or making the objects mimic the behavior of the system you're trying to model is as simple as setting these property values. And there are lots, you can see over here on the navigation, there are lots and lots of options. And as I mentioned at the very beginning of the presentation, we're really just going to scratch the surface of those capabilities. And so lastly, on the behavior of our really simple model is this decision when an entity leaves server 1, how does it decide between server 2 and server 3? Since we haven't said anything, what happens is Simio is going to randomly choose and select server 1 and server 2 with equal probability. So half of are going to go to server 2 and half are going to go to server 3. And that is implemented by something called selection weights. So you can see my path 2 has a selection weight of 1. And my path 3 has a selection weight of 1. So that's telling Simio take the sum of those, which is 2, and then for each path, take its weight divided by that sum, so 1/2, and sample the destination accordingly. So I'm going to make a little change here and say I want 33% of these. So I want roughly 1/3 to go to server 2 and 2/3 to go to server 3. So I just changed that one to the top one to 0.33 and the bottom one to 0.67. And now we have 2/3 of the entities will go to server 3 and 1/3 go to server 2. So that's sort of the general behavior. That's the general method that we use to customize the behavior of these standard library objects. So next I want to go back and revisit our results. Now that we've set the property values, I'm just going to fast forward really quickly here to 24 hours. And then I'm going to go back to the results that we saw before. And so now that I've set those values, ostensibly we would be interested in these performance metrics. And what I'm going to do next is I'm going to take my pivot grid and filter it to some performance metrics of interest. So I'm going to go to my data items and just expand that, and I'm going to pick standard queuing metrics. So I'll just unselect everything, pick number in system, scheduled utilization, and time in system, and click OK. And you can see that it instantly filters my results. And then I'm going to just filter my statistics so that I only get the average values and the percent value for my utilization. And so now what we see is for my entities, I can see the average number in system and the average time in system. For my 3 servers, I see their scheduled utilization. And then I have a second measure of time in system based on the sync. So in our model, all of the entities in the population went through the same sync. So these 2 measures are identical. And so I can then, now that I've filtered my view, I can add that view and save it. So I'm going to just leave this default as view 0. And now I can go back and change my view. If I want to go back and see all of the results, I can do that. If I want to create multiple named views, I can do that. And it lets me quickly hone in on those performance metrics that I want to look at. And so this pivot grid view is one of the fundamental or the main mechanisms that we use to look at the simulation results. All right, so I'm going to stop here on this one and then take a quick look in a couple of animation features that are quite useful. But before doing that, what I want to do is demonstrate how we can duplicate a model. And so in the general model building process that I use, I typically start with a base model and then copy that model to add successive features. So I really want to just demonstrate that capability here. So I'm going to go over to my model over in the navigation window and then right click and go to duplicate. And now you can see I have model and I have model 1. I can rename that to be whatever I'd like. And this is going to be the starting point for my addition. And we'll see this here in a little bit where I do this on a pre-built model. The animation component that I want to look at first is a fundamental component of Simio called symbols and symbol lists. And if you look at this model, one thing that we commonly see is that I want my entity, as my entity progresses through the system, I want it to change its view. I want it to look different as it moves through its path. And so the way that we do that is through something called the symbol list. So if I click on my entity and then I go look right up here in the symbol ribbon, you can see that I have something called the active symbol, and what this is showing me is the symbol list. And I only have one symbol in my symbol list right now, so I'm going to add a symbol to it. And now we can see our active symbol. We have 2 symbols. We have symbol 0 and symbol 1, and they're both identical, both the green triangle. So I want them to look different, so I'm just going to grab symbol 2 and then change it from green to red. And now if I go back and look at my symbol list, I now have that same list, 0 and 1, one's green, one's red. I'm going to add a third symbol here, and then I'm going to change its color to this nice blue color. And so now we have 3 symbols in our symbol list, 0, 1, and 2. And so when I run my model though, nothing changes, right? Because I still have my symbol list, but I haven't said where and how I want to change the symbol list values. So the way that we do that is if I look at my default entity, again, over on the properties, you can see I have this current symbol index model entity.picture. So model entity.picture tells me which index I want to use. So what I'm going to do is go change that value. I'm going to go to the path 2, and over here on properties, I'm going to add a state assignment and say when an entity enters this path, I'm going to change that value. Model entity picture, and I want to change it to 1. And then I'm going to do the same thing here on path 3, I'm sorry, except I'm going to change it to 2. So I'm going to go here and say model entity picture 2. And now when I run my model, you can see when entities jump on this path to go to server 3, they're blue. And when they jump on the top path and go to server 2, they're red. So what we've done here is a fundamental component of Simio's animation. So let me just jump back here really quickly because this is really important. If I can switch back here, and this critical concept of symbols, symbol list, and then an index and pointer. So we had a symbol, we have a symbol list associated with that object. We changed the look on those, and then at some point in the model, we changed the index or the pointer. In this case, was model entity.picture, and then the visualization, the animation took on that new picture. If we look at our servers, they already have built-in symbol list, and so you might have noticed when I run my model, I didn't point this out, but when a server is busy, they turn green. Well, that same mechanism is at work here. And then when I look at the server, you can see an active symbol. It has a longer symbol list, and that symbol list is indexed by the server resource state. And so that's automatically tracked inside Simio to where when the server becomes busy, it changes from state 0 to state 1. And that's why, as you see, it turns green. So again, back to my PowerPoint, these are identical concepts in that we have a symbol list, we have an index and pointer. The only difference is this pointer is model entity.picture for my entity and server.resource state for my server. And so this symbol and symbol list concept is really important. So another thing I want to look at is how we change the symbols themselves. So we did a really simple change and just changed the color of this one. But I'm going to go to server 2 and click on that, and then I'm going to go up here to my symbol and say I want to apply a symbol from one of Simio's internal libraries. So I'm going to click on that, and then I'm just going to filter this down to equipment. And I'm going to choose this press. I'm going to choose press 2. So when I click on that, it replaces the symbol, and I'm going to jump into 3D mode. I just hit the 3 on my keyboard, and now you can see that our standard or default symbol index has been replaced by this press. And so when I run the model, this press is not an animated symbol, so it just shows that it just shows the same press. You'll also notice that it doesn't change color. So if I go back and look at my symbol list here, you can see that when I replace that symbol, it replaced all 9, but it didn't update the color. And if I want that to happen, I simply choose that one, choose the one I want to change, go back and say, we'll make that green. And now we've just changed the symbol list, but the behavior of the system is going to be the exact same. So now when an entity comes to that server, you can see it turns green. One last thing that's useful here is that you can see we have this press, but we have the processing that's going on in this processing queue. What we would typically do is I'm going to go back to 2D mode and just sort of drag this queue around. You can see I'm doing this while the model's running, which is pretty useful to be able to see how it's moving. And I can actually move that processing queue so that it actually looks like the model is being, the entity is being processed. And so that's just a quick overview of how symbol lists work using the symbol index for our to implement animation. And as I said, it doesn't matter what the object is, whether any object from the standard library or from any of the other libraries has the same basic feature of having a symbol and a symbol list. You set the symbol list, and then you control the index to that symbol list to make the animation change. Okay, so I'm going to now switch from the model that I built from scratch. I'm going to switch over to a slightly pre-built model where all I've done between the model that I just showed you and this model is tweak the animation just a little bit, and I've replaced 2 of the paths with conveyors. Okay, so again, I just tweaked the animation. Hopefully this doesn't cross the bar into hand waving. I just did more of what I just illustrated. I just did it all offline. So if I jump into 3D mode, you can see here's my press that I had before. I replaced server 3 with a type of turning operation, and then I've replaced server 1 with a with a stove. And so one of the things that I wanted to mention, or that we're not going to have time to cover, is another option for using symbols. I'll let this run while I talk for a second. And this other method for using symbols is by importing symbols from the Trimble 3D warehouse. So if I go back, I'm not going to demonstrate this, I'll just point it out. If I go to my entity, we have this go to 3D warehouse option. And if you do that, if you click on that, what it will do is it will open SketchUp or Trimble 3D warehouse, and you can download symbols, and you can use those symbols, import those symbols into Simio and use those for your animation. So I was going to do this in this model. My objective, since I have a press operation, I have a little turning operation, I was in the Trimble 3D warehouse and I was looking for a cylindrical part that makes sense to have. These operations, and I didn't really find anything, but what I did find is a really cool Oreo 3D object. So I grabbed that Oreo 3D object. You can see here I have it shown in 3 dimensions here. And because I have a press operation and a turning operation, I needed to have 2 views of my Oreo. I needed to have a vertical view and a horizontal view. So to implement that in the animation, I did the exact same thing that I showed you. I just didn't change colors. I have my default entity. I have my active symbol of a flat Oreo and a vertical Oreo. And then when I run my model, the Oreos stay flat except when they're in this turning operation, where I change them to be vertical. And so that just kind of illustrates this method where I can use the symbol list to make the entities appear different as they move through the system. One other thing that I did in my animation is you can see that I added a couple of status labels that just show how many entities have gone through the corresponding processes. Okay, so I'm going to take a quick pause here and ask Dan if there's anything you want me to address, or you just want me to move forward.
Nope, a couple questions have popped in, Jeff, and I'm glad you took a breath there because that was 30 minutes worth of a mouthful, so appreciate that.
I don't usually take breaths, so you have to interrupt me.
No problem. Real quick question, what keys do you use, again, to switch quickly from 2D to 3D?
2 and 3, 2 for TD, 3 for 3D. 2 for 2D, 3 for 3D.
Perfect, perfect. Next one, can behavior be adjusted to change during the run and not remain constant during the run? For example, have the server capacity change depending on how big the model entity is?
Yes, the server capacity, some of the properties you can, or some of the things can change during the run and some cannot. That capacity can change during the run. That's one of the more detailed things, is what changes and what doesn't. Some can, some can't. For those things that you can't change, though, you could build a custom object that would allow you to change those things.
Okay, perfect, perfect. And then the last question, this one I'll answer. The question was about a recording of this event. Just to remind everyone, this session is recorded. It will be on simio.com. We usually have it up there in about 24 to 48 hours. If you go to Simio, it'll be right on the tab where the solution series is located. You can watch it from there. All right, no more questions right now, Jeff. Back to you.
Okay, so I've got this nice model now, and now I want to add a couple of features and demonstrate some of the other components of Simio. So now that we have we've sort of started down this path of having our Oreo processing facility, one thing that I'd want to do in place of my sink is I want to package these. So I want to, as Oreos come off the line, I want to package those together. So to do that in Simio, the easiest way to do that is I'm going to delete that path. I'm going to delete this conveyor, maybe. There we go. And I'm going to move my sink. So I'm just going to move this stuff down here. And the way we want to do that in Simio is I want to go over to my standard library and grab something called the combiner. And what the combiner does is it batches entities, what are called member entities, using a parent entity. Okay, so we're going to create a batch of Oreos by routing the Oreos from the 2 processes into the combiner. So let me just jump and do this really quickly, and then we'll talk about what's going on. So I'm just going to connect these up. I think let's go back and use the conveyor. Oops, not connector. Typing and talking same time. Let's see. So I'm just going to go the output there, and then go over to this input, and then I'm going to put another conveyor from here to here. right? So those come into the member. And the way the combiner works, as I mentioned, is it uses what's called the parent to batch. So I need to use another source here, and I'm going to create another entity type. I'm going to call this guy package. And I want this source to create packages. And when it creates a package, I want that package to go to the parent input. And so what this is going to do is it's going to create a package, and then it's going to batch those Oreos coming in, and I can specify how many. Let's say we want to have a batch quantity of 6. The last thing I need to do is specify the arrival process for my packages. And I want this to behave a little bit differently. Rather than using an in arrival time, what I want to create a new package every time the previous package is full. Okay, so I'm going to do that by changing the arrival mode to something called on event. And the event that I'm looking for is when it leaves the combiner. So I scroll down and I've got output at combiner 1. And then I need to give it 1 priming. And then I will go and add another conveyor to the output here. And so now when I run my model, what should happen, here's my batch entity right here. As soon as we get 6 Oreos that come into my batch, they should leave the combiner and go down to sink 1. We'll let that go, and while we do that, hope it happens. There you go, you just saw that one. Let me go back in and do one thing to illustrate. I'm gonna go to my package, zoom in a little bit, and then go over to the attached animation part of the ribbon, and I'm gonna grab a queue, and what I want is something called the batch members queue. And as you might expect, what that's gonna show is it's gonna show the entities that are being batched. So when that first Oreo comes in, we're gonna see that Oreo in the batch, and then when the batch departs out of our sink, we're gonna actually see that too. So there are 2, 3, 4, 5, 6, and there goes the batch. So what the combiner does is it gives me a really easy way, a really simple way to batch things together using this parent object concept. Now, we use the very simplest default combination. We basically take any Oreo, take the first 6 and batch them, but we could do a whole bunch of different variations of that where we batch by time, by type, and other things. One of those we'll see a little bit later. So I'm going to stop here on this model, and then I'm going to jump down to my very next model. So I did the same process that I illustrated when I was building from scratch, and all I did between animated model and add combiner is just tweak the animation. So I took that model that I just adjusted and tweaked the animation. So I now have my combiner, I have a nice animated thing for my combiner, my batch entity, you can see that I have a palette. Let me speed this guy up a little bit. So I have my palette rather than just the green triangle. So I just adjusted the symbols, adjusted the symbol list, and now we can see we're creating palettes of Oreos. So the next thing I want to illustrate here, the combiner, is I want to say, suppose that when the palette of Oreos comes down here, I want a person to take that palette to the loading dock. So I'm going to delete this guy, delete the conveyor, move the sink over again, and then I'm going to go grab a transfer node from the standard library, put it right there, connect it up with my conveyor down here, and then send those to the sink. And so what the transfer node does is it says, I want to transfer from one path. In this case, I have a conveyor. So this is conveyor, so let me go add the rollers on it. And then it just delivers it over to the sink. So this is sort of what I want, but remember what I said I wanted was I want a person to do that delivery. So now I'm going to go back and grab a worker. There's my worker. I need to grab a node for the worker's home node, basic node 2. So I'm going to go tell my worker, I want your home node to be basic node 2. I want you to park at home. And then I want on my transfer node, when a pallet gets here, I want it to say, use this worker. So I'm going to go ride on transporter, yes, and say, grab that worker. And so now when the pallet gets to the bottom, not only does it not it doesn't immediately transfer, but it seizes that worker and the worker delivers the pallet. So you can see really quickly the worker is delivering. Slow that down just a little bit. And now you can see the worker carrying the pallet over. And so that worker resource adds a capacity constraint. Without the worker resource, as many pallets as come down the conveyor could move onto this path. With the worker constraint, now I have to have a worker that actually carries that. So as before, I'm going to stop this model. I'm going to jump to the next one in my list, where I've just taken that same model and tweaked the animation a little bit to make it look a little better. And one of the things that animation features that I used here is an animated symbol. And so when the first pallet arrives, you're going to see that the worker now, the default worker symbol has been replaced with an animated worker, so the worker looks like she's walking. So there you go, a nice little touch that illustrates this notion of animated symbols that I mentioned back when I placed this first press, saying that you can use animated symbols to make the symbol a slightly different method than using symbol list, but that add a fidelity to the animation. Okay, so the next thing that I want to do here in my
Jeff, can I interrupt you for a second?
Please do. You can.
A couple questions on this subject.
Okay.
How do you add counters for entities going through the server?
You mean these the status labels right here?
Yes.
Okay, so what you do is you go to the animation tab and there's a status label. And then the key to doing Simio modeling that I didn't mention in too much detail is understanding Simio expressions. So you just place the status label and then you specify the expression. The expression that I'm using here is server3.inputBuffer.numberedEntered. So it's going to give me the number of entities that go through this input buffer. So learning how to use Simio expressions, inform Simio expressions, and interpret Simio expressions is one of the most fundamental components of learning Simio. It takes a little bit of time to do it, but that's, we use it in many, many places.
Okay, great. And just so you're aware, there are a bunch of questions popping in, so I'm going to try to get to these as they're popping in.
Okay.
Can custom code be added to give the model more details on how to make decisions?
Absolutely. You can put any level of detail that you want. If you have something like, I want this worker to wait till there are 9 pallets, or I want the worker to take 2 pallets at a time, that kind of logic can easily be added to adjust the standard behavior of objects, or you can create custom objects and do virtually anything that you would like to do. We can't see that in this 45-minute presentation, of which I have about 13 minutes left, but you can definitely do that.
Okay, great. And these are always things we can get back to anyone on. Next question is relevant. Does the Simio library contain vehicle objects where these can pick up and move objects around, and we can adjust the vehicle speed or how the entities are loaded onto the vehicle?
Man, what an awesome question. That's the very next thing I'm going to do. If you look over here on my right, you see add vehicle is my next model. So yes, I'm going to do that here next.
There you go.
Do you want to ask me another one? You want me to jump into that? Yeah, go ahead.
Well, one other question someone asked is, I guess it's their lunchtime. They want to know where they get Oreos this large, but I don't think you can answer that one. So go ahead.
I thought someone might bring that up, but that's a good one. Okay, so as a promise, the next thing I want to do is I want to take my model and say, this person is actually delivering these to a loading dock. They get loaded on a truck and the truck takes them to a customer. So to do that, I'm going to delete that path. Again, I'm going to move my sync down. And now we have another application of a combiner, because what I'm going to do is I'm going to combine pallet loads into truck loads. And so I need another combiner. Just grab that guy right there. And then I'm going to connect with a path, my transfer node to the member input node of my combiner, just like we did before. And then I'm going to specify for my combiner, let's do 4 of these. So 4 pallets to a truckload. These are indeed big Oreos. And so lastly, I need to create my new trailer load. So I add another source. I add a model entity. We're going to call this guy trailer. And then I'll use the same that I did before, where I specify the type of entity that I want to create. I want to create a trailer. I want it to be on event, and I want that event to be output at combiner 2 exited. So when I talked about using Simio expressions, when I talked about status labels, these are all Simio expressions. And so learning how to do these, you need to learn how to use these to do the to implement the logic. So I was talking and I wasn't listening to what I was doing. So output at combiner 2 exited. Here we go. And then I'll just connect this to the input here. And then I'm going to move this node, and you can see I'm moving these nodes on the objects around so that it enhances my animation. And then I'll just take my output path and we'll make a nice route for our vehicle to take here. There we go, there's to our customer. And so now what should happen, we'll all hold our breath. I have a batch quantity of 4. When I have 4 pallets down here, we're gonna see that the entity, the new trailer entity moving to the sink. As I did before, I'm going to go to the trailer and go to the attached animation, attach my batch member queue. There we go. Oops, I forgot to have my priming create right there. There's our first trailer. And so now we have to wait for there to be four pallet loads. Speed this up. Okay, there's our first pallet, person takes it, sitting in the batch queue, 1 down, 3 to go, 2 down, 2 to go, 3 down, 1 to go. And there we go. And there's our truckload or trailer load that's going from the output of the combiner to the input at sync 1. So this is very similar to what we did here with the worker. I did this in sequence in that I added the node first and then went back and added the worker. And so I'm going to do the same thing with my vehicle. I'm going to go over to my standard library vehicle object. I'm going to grab a vehicle. I'm going to grab a home node for my vehicle. I'm going to tell my vehicle what its home node is. So this is basic node 3. And I want it to, I want it to park at home. And then I go and say use a vehicle. So I click on that output node and always use vehicle 1. And let me speed it up again, because we have to wait for 4 of them to see if it's going to work. First one, second one, third one, fourth one. Oh, I used the worker rather than the vehicle. That was pretty cool, but I don't want to do that. I want it not to be worker 1. I want it to be vehicle 1. There we go. And I'm not going to rerun it now. I'm going to do as I've done previously, just jump into the version that I've already tweaked the animation some, and we can talk from here. And you can see that I've changed the animation for my vehicle. I have this nice little panel truck. I also have what's called a floor label, which reports some statistics as the model runs. There's our first truckload going to the customer. So you can see it's pretty simple to put the vehicle in. The questions about loading and unloading, that all comes with the vehicle object. So I don't have any loading time, but I could have loading time. I could have another worker resource, so I have to have a specific worker to do the loading. I could make this worker do the loading. All of that is doable with the standard vehicle object. So Dan, I'm going to pause here if you have any questions. By my clock, I have 7 minutes left. I have a couple other things to show, but I want to answer the questions that we think are pertinent before I do that.
Yep, absolutely. How do you rotate an object again, please?
You can rotate the screen by just right-clicking and moving around. To rotate an object, hold down the control key and get that little red thing, and you can rotate that. And remember, when I move the object, the nodes move with it, but I can move those nodes independently of the object itself.
Okay, perfect. And there are so many questions coming in, Jeff, that we're probably not going to have time for all the questions. So I will warn people, if we don't get to your questions, I do apologize. But when we get to the end, I'll flash our emails up again. So if we don't address your question specifically, you can reach out to us directly.
I tell you what, Dan, how
question.
about if I just zip through these last three things, and that'll leave a little bit of time, and you can pick the questions you want to ask me. I want to just show these three things really quickly. I'm going to go a little bit faster than I have before, because what I did in these next three models is the first one I added an experiment, because in general for a model like this, we want to use the model to do some kind of assessment. So in this model, I created an experiment where we can set the inner arrival time for my Oreos, and the inner arrival time is going to dictate that throughput. And so we can use that inner arrival time to look at in this case, I just took the utilization, right? So I look at the oven utilization, the press utilization, the lathe utilization. And if I go down and say, let's add another scenario where I increase the arrival rate, right? So I went from 0.5 to 0.25 and now run. And now we're going to see we're creating more Oreos, right? We're creating them at a faster rate. And so the utilizations are going to be higher. And so this type of experiment we could use to say something like, what's the maximum rate of Oreo arrivals that I can handle, right? And if I look at my utilizations, this one, the lathe utilization is around 90%. So it's probably going to be the bottleneck. I can keep tweaking it and get to that point. So that's really the idea of experimentation. And the last two things, or the last concept I want to talk about before I open it up is the concept of using data tables. So in the add table model, what I did was I said, I want to create 3 different flavors of Oreos, because we don't want to only be focusing on chocolate Oreos, because we all know there are vanilla Oreos and lemon Oreos out there, among others. So I created this data table, and I'm now driving the arrival process based on the data table. So when I run this model, you can see I have my chocolate, vanilla, lemon Oreos, and they get created. And in this particular model, I have it set up to where they get created randomly, 1/3 chance of chocolate, vanilla, and lemon. Other than that, the behavior is the exact same. So that arrival process is controlled exactly by this data table. So if we introduced a new flavor of Oreos, to introduce that into my model, all I would have to do is add another row to this table and then add the corresponding entity instance, and we would be able to create that that new type. I wouldn't have to tweak the model behavior at all. And the very last one is I added another level, a table here, where instead of producing random arrivals of Oreos, I'm producing orders. So this is what you would see. I'm producing 120 chocolate Oreos and 48 vanilla Oreos and 48 lemon Oreos. And so when I run now, instead of having random arrivals, I'm using batch arrivals that are scheduled at specific simulated time. So you'll see here, I think we've gotten our 120th chocolate Oreos gone through the baking process. And the next arrival time, I think it's around 0.6 or 0.65, 0.06 or 0.065. We're going to see I guess the vanilla ones arriving next. There you go. There's my vanilla Oreos. And then when they finish, my lemon Oreos start arriving after that. And so by this data process, and this is a fundamental use of Simio, is by incorporating data. Fortunately, we didn't have enough time to cover that in detail here, but that's definitely been topic of previous and will be future solution series also, about how to efficiently use data tables to control the behavioral model. So there we see our lemon Oreo is there. Okay, that's my last model, Dan. Ask away.
All right. And like I said, after we're finished going through the questions here, I will bring up our email addresses again, just in case we don't get to your questions. So I'll try to get through as many as I can. I appreciate everyone sticking around as long as you have. It looks like pretty much everyone that came is still here. We've only lost a few people throughout the entire session, so great job, Jeff. Is there an option to export 3D model in animated formats, such as FBX, to use in another application?
Not other than like screen capture type exporting. So there's not a model export, there's just an animation export from like a screen capture kind of thing. AVI, okay, or use another tool, an external tool.
Okay, so there is an option. It's just it's not necessarily that FBX, so it would be AVI or something like that.
Yeah, it doesn't create a 3D model. It just creates an animation.
Got it. Simple question, tutorials for sample models to practice with Simio. I know you talked about this at the beginning, but would you jump into that again and just talk about the best way for someone to start to get into Simio and get up to speed?
SimBits are the best bet. So if you look at SimBits, you're going to see a whole bunch of, again, what we call SimBits, which are just very small models that illustrate specific points. It's searchable. You pull this up. I'm not going to do it here, but if you pull up one of these models, it gives you the model, it gives you a PDF with the specific steps to do that. So that is the easiest, the best place to go. We have example models and books and so on are also there, all available through the support ribbon.
All right. Can you import a custom animated visual to add to entities? If so, what formats can they be?
You can. So when you go to, as I mentioned quickly, this 3D warehouse, you can also import. So 3D warehouse uses SketchUp format. I am nobody's expert on these formats, but 3D warehouse uses a particular format, and you can import any objects that were created to that format and others. And again, I'm sorry, I'm not familiar with our exact import, but you can import standard 3D models using the same process.
Okay, all right. Can the size of entities be changed after they exit a server?
So there are two answers to that question. One is if you want to change the animation, yes, you just simply add a new symbol, symbol to the symbol list, just switch the symbol. That's the easiest way to do the animation. If you want to actually change its physical size, it can be done, but it's a little bit more involved. I'm going to leave that off for now because it is a little bit more involved.
Okay, no problem, no problem. Question about your model that you're using here. Are you able to share this model? There's nothing proprietary in this, correct?
There's nothing proprietary in this. I will say I did this all in version 16.358, which is the 258, which is the latest version of Simio. So happy to share this model, figure out how to share that, but it does require this version of the model, this version of Simio.
That's fine. And what we will do is, as we've done with other models, excuse me, is we will put that on along with the link. When you go to watch this video and record, we'll have a link there to download the model from this session, so you'll have that ability. All right, can custom statistics be added to the pivot grid? And also, same question, can the status labels be added to the results table?
So I really breezed through the experiment. So I'm going to answer the question about the pivot grid a little differently, in that you typically wouldn't add it to the pivot grid. You would use this either a experiment response, which also has much more detail than I showed earlier. You can put custom statistics there. You can put custom statistics in dashboards. If I create a custom statistic, it will show up in the pivot grid. And so you can filter the pivot grid to your custom statistics and so on. But typically we find that there are better, more effective ways to specify that, or to show those statistics than by putting them in the pivot grid, but certainly can do that during development.
All right. Pretty specific question, and I'll put this maybe in generic terms, but I know you already talked about this, but from a symbols perspective, someone's asking, is there an airplane symbol entity, or how would you get an airplane symbol entity?
So if you go to symbols, you can look at, you have Simio's library. It's got a whole bunch of things. I can tell you what I do. What I do a lot of times is just go to 3D Warehouse and search for it. So again, you have to be logged in to do symbol 3D Warehouse. So if you go and search for something, airplane, and a model. And so there's a whole bunch of models. So there's a Delta plane, a view in 3D. If I want to grab this in Simio, if I want to get this in Simio, there you go. Just go download the SketchUp file, import into Simio. That's how I would do it.
Perfect. All right, we are just about out of time here. We still have a pretty sizable amount of questions in the queue. Let me ask one more, and if I haven't asked your question, once again, I do apologize we didn't get to your question. I'll flash our emails up here before we leave. So last question, Can the size of, we already asked that one, hold on. Is there anywhere in the pivot grid or other results that display the wait times or number of entities waiting at a given location?
Yes, so I didn't go through all the elements of the pivot grid, but what the pivot grid shows, if you, by default, in other words, you don't put custom statistics in, it shows those statistics that are embedded in the standard library objects. And so all of those wait times are there. Wait time, waiting for a server, in the server, waiting if you have like an accumulating conveyor like I showed, then you have those times. So all of that is in the pivot grid. I had to fly through the pivot grid, but it's all there.
Perfect. All right, I'm going to grab control back, Jeff, if you don't mind, just to flash your email addresses. Hold on, that wasn't the right person. There we go. All right. All right, so quick confirm, you can see that email address, right?
Yep.
All right. All right, so once again, if you have any questions that either we did not get to today, I do apologize, or if you have questions that come up as you're watching this recording, there's both my email address and Jeff's email address. You can reach out to either of us, and one of us will get back to you. If it's not, right away, we'll get back to you as quick as we can. We appreciate everyone attending today.
Don't forget the feedback.
And exactly, the QR code, please scan that. Give us some feedback on today's session as well as future sessions. So once again, thanks everyone for attending. We appreciate everyone sticking around to the end here. We appreciate the extra couple minutes you gave us, and we look forward to seeing you again in about 2 months. I'm sorry, here, bring up this one, on April 18th for our next solution series. And then once again, in less than a month, Simio Sync 2024. Please get registered for that. We look forward to seeing you there. Jeff, thanks very much. Great presentation. Everyone have a good rest of your day, and we'll see you in a couple weeks. Bye all.
Thanks, everybody.